Hello and welcome to my stream. Today we're going to be doing a lesson on the Google Certified Associate Cloud Engineer Certification Udemy lesson. That was a mouthful. Um, and we're going to start off with, I think I'm on section 1. And I guess this is labeled as Section 1, Unit 3, I think is how they call it. Anywho, let's get started.
Cloud Gurus, and welcome to this course. I'm your instructor, Matthias Anderson, and in this course, I will show you how you can use the Google Cloud well enough to become a Google Cloud Certified Associate Cloud Engineer. Whew, that's a bit of a mouthful, eh? I myself have been certified by Google as both an Associate Cloud Engineer and as a Professional Cloud Architect, which is something you might also want to go for after you finish this Associate Level 1. Now, if you're wanting to learn how to use the Google Cloud Platform, then this really is the course for you. In this course, I'll answer questions like, how do I properly set up my GCP account and projects? How do I set up and use the various GCP services? How can I build a GCP system that I or someone else has already designed? And how can I get certified by Google as an Associate Cloud Engineer? So to accomplish this, we'll start off with a quick look at the target, the certification that Google's defined. Next, we'll dive into GCP and set up the account that we're going to use through the rest of the course. After that, we'll take a look at a bunch of different Google Cloud services, including setting them up and getting a feel for them hands-on. Finally, we'll circle back on the certification and make sure you have everything you need to pass that exam and get certified. Now, throughout this course, you will definitely get a lot more out of it if you follow along and don't just watch what I do. And ideally, you'd use the technique that they often use in medicine, which is see one, do one, teach one. For lab videos, start off by watching the whole.
Actually, I'm interested in that quote, so let me copy that down. See one, do one, teach one.
whole video through once first. Don't try to follow along the very first time. After you've seen me do it, then go ahead and try it yourself. Now, it'll be hard to remember everything that you just saw, so you should probably replay the video and pause it as you're doing the steps yourself. After that, if you really want to lock in what you've learned, find someone to tell about it. Our forums are a perfect place to answer questions that other students are asking, or you can try and find a family member, friend, or colleague that'll listen, and if that just simply won't work, then find a mirror. Try to explain it to yourself even, just so you've gone through the motions of that. Now, when you're all finished this course, you should end up with a GCP account that you can use to build stuff, a good solid understanding of how to use all the key GCP services, and you should get what you need to know to get certified as an Associate Cloud Engineer.
Key takeaways. Usable and configured GCP account. Good, solid understanding how to use all the key GCP features or services, and what you need to know to get certified as an associate cloud engineer.
Now, before you dive in, let's talk for a second about prerequisites. The certification exam itself has no prerequisite. Google doesn't require you to do anything or prove anything before you're allowed to take this exam. You could go and sign up for it right now. Of course, the reason you're taking this course is because you want to be ready for that exam when you do take it. So in terms of taking this course, one thing that you should know is that you'll need a credit card to set up your GCP account. Now, if you leave that account as a trial account, you won't get charged at all, but Google still requires you to put in a credit card for their own verification. Another thing you'll need is a computer to connect to GCP itself and to the virtual machines that we'll be using. But really, any operating system would be just fine, even a Chromebook. but you'd have trouble if you tried to do everything on just a mobile phone. Another thing I should point out, Google actually has a fairly similar certification system to AWS. In particular, both Google and Amazon certifications require that you have strong mental models of how the platforms work. So if you're not right now saying, well, of course, that's the only way to learn effectively, then you'd probably get a lot of value out of going through that. Now, something to call out though is that you really don't need any AWS experience at all. Not to be able to learn GCP, neither to be able to take this course, nor to pass Google's exam. Alright, just so you know a little bit more about me, my background really is in software development. I spent a number of years writing code in Microsoft Office, but I've done a bunch of other things since then too. Lately, I've really fallen in love with the way that the serverless way of doing things can simplify the building and running of distributed systems. But I do understand that not every circumstance is best served by a serverless approach, and we'll definitely also be looking at some of the traditional approaches in this course. Now, as far as GCP goes, I'm also a Google Certified Professional Cloud Architect, and I hold a bunch of AWS certifications too. But like I said, don't worry if you don't know AWS. It could help, but it's really not necessary for this course. But speaking of this, let's take a quick look at your background. You, the student, I mean. Now, as I've already said, you don't need any previous experience with GCP or AWS to take this course. But there's no question that a number of you will have such experience. And there's a lot more than just these two things, too. Things like Azure or Kubernetes, or just building distributed systems in general. And even experience with things like Linux or the command line or programming in general. Those could all have an impact. Any one of these things would be an asset to you, including the etc., because this is definitely not a full list. But none of them is required to be able to take this course. You might have no experience with any of them, and that's okay. But I wanted to call it out because I think it'll help you better understand how I've designed this course. In particular, there are two key principles that I try to always follow. I really respect your time, so I want this course to be as efficient as possible. I want you to learn what you need to learn, but I don't want you to waste hours and hours on stuff that isn't important. This was actually one of the critical factors in my decision to use A Cloud Guru courses years ago. I was comparing an A Cloud Guru course to a course from another provider, and I had to ask myself, is it more valuable that that other course is so long, or are they just going to be wasting my time? It turned out that the A Cloud Guru course was just really efficient, so I was really happy with my decision to use that one. Now at the same time, I want this course to be really accessible. I want you to be able to follow along with this course and learn what you need to learn, regardless of your background. Now, if I were designing this course for only you, by yourself, then it would actually be pretty easy to make sure that it is both efficient and accessible. I would figure out where you are at, and I would teach you all and only the things that you would need to know. But given the very wide range of students that we have in this course, these two things are in a bit of contention. But that's okay too. It just means that you will have to approach this course a little bit differently than if this were one-on-one tutoring. You need to take an active role in making sure that you're learning the things that we're covering. So let me explain. At the start of this course, I'll go into a lot more detail and demonstrate a lot more things. But as we move along, I'll move faster, expecting you to practice the things we've already learned off-screen and join up with me for the labs. By the end of this course, you'll be able to do a lot more independently. You'll be able to work through the homework I give you, and you'll be able to choose from the hundreds of available code labs to fill in the gaps in your understanding. You'll go through our exams and be shown what you are missing, so you can spend your time studying what matters most to you. Now, for those of you with a very strong background, like you've already been working with all of the things I listed on the previous slide, this should make for a very efficient way for you to get ramped up. You may even want to increase the video playback speed, though I don't recommend that you completely skip any of the lectures. Now, for those of you at the opposite, just getting started end of the spectrum, you will definitely need to work harder at this, but it should still be accessible. You will need to go more slowly, maybe read more of the linked resources, repeat more of what you go through, both videos and labs, and ask more questions. This is fine. This course is also designed to accommodate you. Now, for most of you, you're not at either extreme of this spectrum. Each of you, though, will have your own unique background. Some of you will have used Kubernetes for years, but have never touched AWS. Others of you will be masters with Azure. Some of you may have been programming for years, but this is the first time you're jumping into the cloud. Or you could be looking to make a career change entirely. And that's why I think this course will also be very effective for you. For the different things we cover, I will try to give you a quick primer on the background stuff you need to know, but I won't go into so much detail on everything that you'll go crazy if you're already familiar with that. And I will also point you to additional resources for follow-up, so you can quickly ramp up on whatever the things are that you haven't encountered before. And if I don't remember to do this for something, then just ask. Both I and the other students would be very happy to recommend some additional resources. And this leads directly into the next thing that I want to call out. Now, as you go through this course, you should realize that every lesson can have some discussions that are attached to it. You can find these in the panel beside the video as it's playing. This gives you an opportunity to both ask questions and answer them, and you don't even have to be writing something all the time either. You can just read and vote on the other things that other people have been writing. Now, these aren't face-to-face discussions like you might have with other students in a classroom, but just like the video lessons, these work on your schedule. If you have a few minutes on a break, go ahead and read a few things. It'll really help you learn things if you talk about what you're learning with other people. Now, a lot of these discussions will be students talking with other students, but I'll definitely join in on some of them as well. And you can also connect with me and message me on LinkedIn. Oh, and about that little box in the corner of your screen, I will often put QR codes like this into the lectures. These are simply one option for how you can link to that particular resource, so you have something to read on your phone or tablet when you're standing in line at the grocery store or whatever. You should always be able to get to the same link from the resources section for that particular lecture, so let me know if I've forgotten to add it. But if you want to open it on your phone, you can use any QR code reader, like Zing or however you pronounce that, or on a newer Android phone, you can long press the home button and ask Google what's on my screen when it's displaying, even in the camera app. Well, alright, let's start on the path to certification and dive into the Google Cloud Platform. If you have any questions already, please let me know. If not, please join me in the next lecture and we'll get started.
Alright, I copy this so that I can connect with them later.
Thanks. Okay, hello class.
Alright, where are we? Okay, that's, what is this? Oh, it's just a link. Well, actually, let me just do that now. I mean, oh, well, interesting. I'm already connected to him. And I'm not sure when I actually did it. I think he might have taught another course on Udemy, and I might have connected with him before, but yeah, awesome. Okay. Oh, hey, look, there's resources here too. Oh, this is just where you need to go to register for the exam, but okay. Add a new section here, S2 dash certification intro. Over here in our first page, right, 4 dot exam guide. I suppose linking that here is important. I wonder what would happen if I try to copy all this and paste it in. That works.
Cloud Gurus, and welcome to this lecture. In this lecture, we're going to take a look at the exam guide or blueprint that Google has written to tell us all about their certification exam. Now wait, in case you're a person who really only cares about learning GCP and doesn't care about the exam or certification, just hear me out, please. Now, the purpose of this exam guide is that it's Google's statement of what's most important to a person who wants to pass this certification exam. But it's more than that. This is also Google's statement of what's most important to a person who's working in the field as a cloud engineer. The Google certification team has gone through a lot of effort to understand what it is that cloud engineers actually do, and what they found forms the basis of this certification exam. So what that means is that this exam guide defines the scope of the role first, and that then became the scope of the exam. And because we're using Google's insight of what's most important, this defines the scope of this course as well. All right, so let's take a look at the job role description that they've given us. They say, an associate cloud engineer deploys applications, monitors operations of multiple projects, and maintains enterprise solutions to ensure that they meet target performance metrics. This individual has experience working with public clouds and on-premises solutions. They are able to use Google Cloud Console and the command line interface to perform common platform-based tasks to maintain one or more deployed solutions that leverage Google-managed or self-managed services on Google Cloud. Now, this looks a lot like a job posting that you might come across. And of course it should. Google designs their certifications to match real-world roles. But this is a lot of words, so let's break it down. This person, they say, will deploy the applications. This means they take the source code and make it available by running it so that the end users can actually use the system. But they don't just put it into production, they also monitor the operation of multiple projects going on at the same time. But they're not just watching things either, they're also maintaining things to ensure that they meet the target performance metrics. If things start failing, they'll definitely try to fix it, but this is also talking about if things are getting too slow or whatnot. Now, this header calls out that this person should have experience working with public clouds and on-premises solutions. That's an interesting thing to note in a certification that's all about the Google Cloud Platform, right? Now, this could refer to either fully on-prem situations or hybrid ones, but I think the key thing to focus on is that there are a lot of tools that aren't necessarily cloud-specific, and there are situations that need to think about more than just the cloud itself. Continuing on, Google calls out that you do need to be able to use the Google Cloud Console, but if you don't know how to use the command line interface, you don't meet the bar here. So we'll include some of both in this course. They say you need to be able to perform common platform-based tasks, which is fairly general, but we'll get into more details later. And kind of what they were talking about above, maintaining one or more deployed solutions, but this time they tie it to leveraging services on the Google Cloud. Now, after this introduction section, they continue on to break the entire exam scope down into sections. These are sometimes referred to as exam domains. Section 1 is setting up a cloud solution environment. Section 2 is planning and configuring a cloud solution. Section 3 is deploying and implementing a cloud solution. Now, in this case, implementing is more meaning putting it into production than it is writing the source code for it. Section 4 is ensuring successful operation of a cloud solution. And Section 5 is configuring access and security. Now, the exam guide breaks each of these sections down into subpoints, and then further offers example tasks for each of those subpoints. Well, most of them anyway. In this lecture, we're going to take a look at the subpoints, but not all of the example tasks. I do highly recommend that you go and read through the entire exam guide yourself, and the sooner the better, really, but you'll definitely also want to read it several times over as you're approaching your exam. All right, let's dig into Section 1. Setting up a cloud solution environment is broken apart into setting up cloud projects and accounts, managing billing configuration, and installing and configuring the command line interface. This is really about getting everything going, making sure that you're following best practices, and that you can start something from scratch. This is also where we'll start in this course, so that you have an account set up you can use for the rest of the labs. Section 2 involves making sure that you know what you're going to do. Planning and estimating a GCP product using the pricing calculator is an important thing to be able to do. If you're comparing a couple of options, you'll definitely want to know how much each of them is going to cost you, right? Of course, to be able to plan or estimate any particular system, You'll need to understand how to use the different options you have available for compute, data storage, and networking. These are the three critical components to data flows, and of course, that's what every system is. And in this course, we're going to get our hands dirty by using the different services. Section 3 is about deploying and implementing the solutions that you have. You have to be able to put stuff into the compute engine, get the machines up and running, get all the code onto it, maintain it. Of course, you have to configure all the attached resources like disks and deal with managing snapshots. You also need to know how to be able to use Kubernetes engine, how to set up the clusters, how to deploy services and deal with load balancing, stuff like that. But those aren't the only thing either. App Engine and Cloud Functions are also quite important. You'll need to know how to use things like App Engine Flex to deploy your own containers, or connect Cloud Functions to different triggers like data services. This data solutions section includes a number of different services, and of course you'll connect everything together using the networking stuff. Now this is all well and good, of course. You could potentially do all of these things manually in the console, but since we're looking at what a cloud engineer would do in practice, there's gotta be automation. And that's why we'd be looking at things like Cloud Launcher, Deployment Manager, and of course the command line interface that I already mentioned. Now once you've got something deployed and running, we need to make sure that it's operating successfully. So that includes managing the compute engine resources, the Kubernetes engine resources, the app engine resources, the data solutions we've set up, and all the networking we've used to connect it all together. But practically speaking, what does managing mean? It means that we're going to have to be monitoring and logging, and then taking action. The final section in the exam guide is configuring access and security. Now, it's not really possible to do anything in GCP without touching the identity and access management stuff. Of course, the easiest thing to do would be to just give everything full control, but that's a very bad idea. So we're going to cover how you can make things a lot more granular. You really want to set things up to use the least privilege that they absolutely need. And one of the tools we have to help with that is service accounts. But access and security isn't just about setting something up and hoping it works. We also have the responsibility to make sure that things are working properly, and that's where audit logging comes in. Of course, that also ties into stuff like compliance. Alright, I hope this gives you a bit of a sense for what we're going to be going through in this course, and what'll be expected of you when you take the actual certification exam. Feel free to read through the entire exam guide at any time so that you can see what the specific tasks are that they give as examples. But that about covers the overview stuff, and we're now going to dive right into GCP. So if you have any questions, please let me know. If not, please feel free to move on to the next lecture. Thank you.
Cancel. All right, let's take a look at the Q&A real quick. What's that? Section 2.4 Q&A. Let's see. Tanankon asks, doesn't need any approval after role of bill account creator from other roles such as bill account administrator. No replies, and I think actually I need to filter down to current lecture. That would be more helpful. Oh, okay, this lecture does not have any questions, so I'm good here. There's no bookmarks. And I guess announcements is global and not tied to that lesson. Let's see, free month of Quick Labs plus new videos on networking. Lots of people have been passing their ACE exams and getting certified. Is it because they added new content? I found out that Google's Quick Labs is currently running a promotion that gives you a free month of unlimited access to their labs for free, as long as you enter the promo code they give before June 7th. I think I'm a bit too late for that. And you can then turn that into 2 months free if you complete their Kubernetes quest by June 30th. Regardless of whether you decide to do the K8 labs or pick other unrelated ones, these can definitely help you get more varied practice with GCP, and will help you achieve both the ACE certification and get you further along towards the PCA, which I am not aware of. Oh, I guess it does not interest me yet because I don't even know what it is. New ACE networking content. Oh wait, that's my field. Another thing I want to call out is that I've just published some new lectures about GCP networking. I created these new lectures because people, like me, have been asking for help on these topics. I'm always interested in getting your feedback, both for existing and new content. And he wants us to reach out on LinkedIn, which is kind of a odd platform, to reach out to him by, when it should be here and also in the QA section, because it'd be kind of all over the place if he's getting messages from LinkedIn, but I guess that's his preference. And regardless of whether you feel you've been getting value from the course, I'm interested in hearing both about things you think could improve and the things that you could finally find valuable, and about the things you find really valuable, because I want to keep up with that too. All right, I think I am good with this section. I will delete this page because it does not apply. S3. Intro to Google Cloud Platform, GCP. Close this up. Where are my resources here? Okay.
Okay, hello Cloud Gurus, and welcome to this lecture about the context of the Google Cloud Platform. Let's start off by taking a quick look at the competition. Amazon Web Services is currently the runaway leader in the public cloud space. One article said, in 2015, AWS delivers over 10 times the utilized cloud capacity of its largest 14 competitors combined. The same source information spun another way said that AWS had 90%, Microsoft Azure had 5%, and Google Cloud and all the other clouds combined had the remaining 5%. Now, the situation might have changed a bit since this was written, but not dramatically.
Let's see. Let me actually write that down. AWS is the market leader. He mentioned something about Azure being second, but it's not on the slide. Azure being second.
Dramatically so. Amazon is still in the lead, and Microsoft and Google are still trying to catch up. But practically speaking, the reason you'd choose a particular cloud is not because a lot of other people have chosen it in the past. You have to ask yourself, what's the right cloud for you? And a small spoiler alert here, you may actually find that it makes sense to combine more than one cloud. But this is taking a look at the external context for GCP. So now let's take a look at the internal context. If you look back into Google's history, its mission statement, what's the right cloud for you? And a small spoiler alert here, you may actually find that it makes sense to combine more than one cloud. But this is taking a look at the external context for GCP. So now let's take a look at the internal context. If you look back into Google's history, its mission statement from 1998 was to organize the world's information and make it universally accessible and useful. Google as a company is all about big data, huge scale. They're literally crawling every single web page on the entire internet. So to accomplish this ambitious goal, Google's hired a lot of really smart people, and they've developed a lot of innovative things internally. Now, some of this innovation has been written up in white papers like the MapReduce or Google File System or Colossus papers. They've also taken some things and released them as open source, like when they released the Kubernetes container scheduling system that they pulled out of their internal tool, Borg.
Oh, I didn't know that. It's kind of important. Released. Kubernetes as open source software. They originated from Linus Borg.
But they've also taken some of these internal tools that Googlers have been using for years and released them as services in Google Cloud Platform. Things like Bigtable and Spanner, or Google Cloud Storage that's built on Colossus.
Commercialized some things in GCP. Bigtable, I don't know what that is, but I'll probably look at it later. Spanner, same deal. GCS, built on Colossus and BigQuery. From Journal. All these things I don't know anything about. Oh crap.
The Amazon Web Services. Now don't get me wrong, AWS has some really innovative offerings, but AWS focuses on automating the undifferentiated heavy lifting, all that stuff that you could do but shouldn't have to. And I feel like the Google Cloud Platform tries to offer a lot of things that you couldn't reasonably build on your own.
How do I get to the transcripts? Transcripts? Where are you? There we go. Where are we? Where are we? Do that.
Another thing to consider.
Google Cloud. So that it differentiates from GCP, somewhat from the AWS. Now, don't get me wrong. And I feel like Google Cloud Platform tries to offer a lot of different things that you couldn't do reasonably. As opposed to Amazon, where, can you say that again?
The undifferentiated heavy lifting, all that stuff that you could do but shouldn't have.
Okay, so I'm thinking what he's saying is that a lot of Amazon's focus is to provide you perhaps tools or I don't know, existing features that reduce the amount of effort that you yourself need to put in. And as for Google Cloud, they'll take care of the things that you as an individual shouldn't have to worry about. And that makes sense to me. I mean, but then who is to say that Amazon doesn't do that as well? And unfortunately, I don't have any knowledge on AWS or enough knowledge to answer that question. So moving on.
Have to. And I feel like the Google Cloud Platform tries to offer a lot of things that you couldn't reasonably build on your own. Another thing to consider is how Google runs its organization. Google doesn't really hire ops people to run its services. They hire software engineers who build stuff and software engineers who build reliability into that stuff. Those people are called site reliability engineers. Now, those SREs are actually required to spend more than half of their time building reliability into services instead of just doing operations. If you want to read more about how site reliability engineering works, they've written a great book on the subject, and you can actually read it on.
Yes. I want to snip this to take a look later. Supposed to be free. Actually check if he linked that somewhere. Oh, okay, there we go. I mean, awesome. Grab that.
Online for free. In any case, now this is just a general sense and it's my opinion, but it feels to me like the Google Cloud Platform was built from the dev side towards the operations and infrastructure side, whereas Amazon Web Services was more built from the infrastructure and operations side towards the development side.
Yes, that's an important point. And I'm kind of too lazy to type it out, but oops, Control Z. Let me underline this point or circle it. Versus I need a different color pen. This isn't too cool. How about the space pen or galaxy pen? Let's see how this looks. Oh, Control Z, Control Z. Okay, cool. That looks pretty good.
Now, I'm apparently not the only person who feels this way, and I came across this really interesting article interviewing Lynn Langett. Now, if you don't know who Lynn Langett is, she knows a thing or two about the different clouds. She's a Google Cloud developer expert, an AWS community hero, a former Microsoft employee. She's a cloud architect who really knows her stuff. And she said, Google is such a developer focused cloud. You code everything first, and then the tools come later, if ever. Even though their cloud is really powerful and really scalable, that's just not the paradigm. Whereas AWS is a DevOps cloud, and I think that's been one of their drivers of their success, around data in particular, because the network admins and DBAs have more references. The key takeaway here is that Google really expects people to have a developer background when working in the Google Cloud Platform. Now, that said, even non developers can use the platform and use it effectively, but there will be more resistance and difficulty along the way. So now let's take a look at the history of the Google Cloud Platform itself, but again, still in generalities. As we just saw, they've definitely grown some of the services internally. These were generally built by Googlers for Google, and the context was not originally for your typical enterprise. It was more for how Google does business. There are also some services in GCP that were purchased and added to the fold. Things like Firebase, Stackdriver, and Apigee. These are some seriously awesome services, but you might know that they don't fit in as cleanly with all the rest of the services. For example, you might need to log into a completely different console to access and use some of those services. It's also important to remember here that GCP has been trying to catch up to AWS. That means that they haven't necessarily had time to build in all the same functionality that AWS has so far. But they've also been able to avoid some of the technical debt that AWS has had because they've learned from their mistakes. In any case, as the underdog, GCP is a lot more willing to be a cloud that you use, not just the cloud that you use. All right, well, I hope that this gives you a better sense for the world around the Google Cloud Platform.
I think this is an important point. I think it's Amazon that would be the cloud that someone would pick by default, and for companies running redundant clouds or multi clouds, it'd be the cloud and also a backup cloud. So, yeah, I think should note this down. Let's grab a screenshot.
So if you have any questions for me, please let me know. If not, please feel free to move on to the next lecture. Thank you.
Okay, let's look at the Q&A. This guy, or Dianash. Well, this guy asks, how do I set up my DNS in I guess this is the host file. while deploying a virtual machine in GCP. Hey, I don't think we even talked about that in this section. So why is he? This guy should be downvoted. Can I? All right. Anywho, moving on. Checking time. We're at 9:43, and what did I say I'll do? How do I check that? Crap, that's not my stream title. Let me fix this real quick. Demi. Change this to. Crap, what does it say on my stream? I got one of these browser tabs down here. Okay, there we go. Nice, updated. Okay, moving on. Let's see. Oh no. Did I complete? Okay, nah, just kidding. So I have one more lesson, and we're gonna have enough time to finish it. Awesome. Okay, I guess you went through all of that yet. Then there's nothing I need to download. Okay, let's go here.
Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we'll take a look at the structure and design of the Google Cloud Platform. First, let's take a look at some of the design principles. GCP has really been designed to be a global offering. Security is also built into every level of the system, and the whole thing scales like mad. Also, as you will remember from our previous lecture, it's very much designed with developers in mind. So let's start by taking a look at the global perspective. GCP is intrinsically global.
Intrinsic global. What does that even mean? I see the transcripts. Wait. Okay.
What I mean by this is that the services are generally built to serve worldwide customers. In this case, I'm not talking about how well it scales to meet the demand of lots of
Services to serve worldwide customers. We're talking about giving good user experience to each of the people in their different locations around the world. What cloud does not cater to different people of different parts of the world? I mean, I'm pretty sure, or I would assume that AWS would be doing the same.
Of people around the world, I'm more talking about giving a good user experience to each of the people in their different locations around the world. Even with the fastest fiber optic networking, it can still take a noticeable amount of time for data to get around the world, so this really does matter. Now, by comparison, I would say that Amazon Web Services is intrinsically region scoped.
Ooh, okay. Thank you for giving a comparison. Actually, that could be a subpoint. AWS, in contrast, is intrinsically region scoped. And what does that mean?
So one of the benefits of the regional model is that it simplifies data sovereignty. You know exactly where your data is physically.
Okay. One. Okay. Which means that we'll use a regional model. And that's what I'm assuming. So what are the advantages to using the regional model? It simplifies data sovereignty. So that you know where your data is physically stored. As the customer users control where data is migrated, if it is migrated.
Because it never moves unless you make it move. That said, the global model is optimizing for a different thing. It makes it much easier to handle latency and failures in a global way, things that would wind up being very difficult.
So Google or GCP, on the other hand, will use a global model. I think unbold all that model. What are the advantages to using the global model? It's easier to handle latency and failures in a global way.
Difficult to do in the regional model. Now, the global model could be more sensitive to failures that affect multiple regions or the entire system all at once.
However, could be more sensitive to multi-region global failure modes.
But that doesn't mean that the regional model is immune either.
Though, damn it, I keep on forgetting to unbold. The regional model isn't immune to this either.
I remember hearing that when Amazon's S3 service was broken in North Virginia, people in Sydney, Australia unexpectedly couldn't use the console. I'll point
Okay, I think that's a good point. Example. So on S3 service breaks in North Virginia. And this also set a chain of chain, and somehow this affected services in Sydney. And when this happens, it's due to put some bold service failures as opposed to underlying hardware issues.
point out that these failures would wind up being service failures, not failures due to the underlying hardware. So let's take a look at the physical infrastructure underlying the Google Cloud Platform. At the very bottom level, closest to the hardware, there's going to be some program that runs on a central processing unit. Those CPUs exist on some physical server in some rack.
Oh, more important things. Okay, on the physical infrastructure slide now. And what are we writing down? Physical infrastructure includes virtual CPUs. It includes a physical server. Includes
rack in some data center. The data center here is an actual building full of a whole bunch of computing capability, and how Google manages this is serious business. One important thing to understand is that they have clear separation of duties. The people who work in the data centers have no access to the services, and the people who work on the services have no access to the data centers. There are a couple of really interesting YouTube videos that you can check out where they give you a virtual tour of the data center. One of them's a more normal video, and the other's a 360-degree tour where you can look all around yourself if you're using Google Cardboard. In any case, one or more data centers together are logically grouped together into what's called a zone. The key thing to know about zones is that each zone is designed to be as independent as possible from all other zones. Independent backup generators, maybe even connecting to different electrical grids, independent network connections to the rest.
All right, what does it say? It's going pretty fast. In any case, one or more data centers together are logically grouped together in what's defined as a zone. The key thing to know about zones is each zone is designed to be as independent as possible from all other zones. Each zone is designed to be independent as possible from other zones. Okay.
Rest of the Google network. If some data center in a zone burns down, that should have no impact whatsoever on anything running in a different zone.
Impact in one zone shouldn't affect others.
So zones are made to be independent of each other, but they're still grouped together in what's called a region.
Okay. Region. What is a region? A region is a logical grouping of multiple zones.
Region. The zones within one region can communicate really quickly with each other. Maybe not as quickly as you could communicate within a zone or a single day.
Okay, latency between. Wait, let me think again. Okay, latency within a region. Between the zones of the same region. Region have an advantage. Obviously, subsystems within a zone would have better latency. Communicating within its own zone.
Data center, but definitely very quickly still. Now, different regions are grouped together in what are called multi-regions. Each of the regions in a multi-region is at least 100 miles away from the others to help address certain
This is a grouping of multiple regions. What does he say? Each region is at least 100 miles apart from others. To address certain kinds of concerns around the physical proximity.
certain kinds of concerns around physical proximity. Now, remember how I said that GCP was designed as a global system? Well, this is where it really starts to show. All of these regions and zones are connected by a private global network.
Oh, geez. Okay. Private global network.
Kinds of concerns around physical proximity. Now, remember how I said that GCP was designed as a global system? Well, this is where it really starts to show. All of these regions and zones are connected by a private global network. Google has strung fiber all around the world to connect up its data.
Regions and zones are via group. How should I word this? Are connected by a private global network.
Data centers. So traffic from one server to another never even has to touch the internet.
Traffic from one server. I keep on not resting my eyes. That's probably not a good idea. Traffic from one server. That's within from one server that's communicating with another server within the private global network. Does not need to ever pass through the internet. They'll traverse across Google. Google, say governed, data centers. And I would consider this advantage. Yes, I don't think many cloud competitors are able to offer the same thing. It's not every company has a global presence in the context of having data centers and having fiber optics running between them. So I think this is one of the advantages of like being one of the top dogs, such as AWS as well.
Of course, some stuff does have to interact with the internet, and that's where the different points of presence come in. These are the edges of Google's private network that connect to the internet.
Goddamn, so many things. Point of presence. Tops. Network edges and content delivery network locations. Oops. Just Google's private network that connect to the internet and a lot of content distribution network locations.
And a lot of content distribution network locations. Altogether, this makes up a global system. So let's take a look at how this looks around the world. This is a map.
Go back a little bit.
Distribution network locations. Altogether,
Whole global system. together above form a global system. Damn it. I don't want to Okay, let me see if I can draw something here. Actually, I should have drew it on the other side, but I don't want to waste what I drew, so... Oops, can I... Control C. Alright, sweet. I want to move this. No. No. This is so hard to, like, maneuver. Let me just click it. Can I rotate it? Because that's really what I want to do. Like, is there a rotation tool? Nope. Alright, that's fine. We just do this. Alright, so I have this bracket and this arrow pointing to global system.
Together, this makes up a global system. So let's take a look at how this looks around the world. This is a map where each pushpin represents a region in the world, and the number on the pushpin tells you how many zones are in that particular.
Jeez. Okay. Looks like he has a link. Is that link somewhere here? Yeah, okay, here we go. What's better? This or this? I think this is better. Okay, just grab this right here. Link this up.
Particular region. There are regions like US.
See the transcript again. Where are we?
Distribution network locations. Altogether, this makes up a global system. So let's take a look at how this looks around the world. This is a map where each pushpin represents a region in the world, and the number on the pushpin tells you how many zones are in that particular region.
Okay. Oh, I mean, I don't have to write that down. I mean, it's right here. Each of these are current regions, and the number within the pushpin is the number of zones. Makes sense.
There are regions like US Central 1, which is in Council Bluffs, Iowa, Europe West 3, which is in Frankfurt, Germany, and Australia Southeast 1, which is in Sydney. The multi-regions are Europe, Asia, and the US, or North America.
Okay, I mean, I guess that is kind of important. Circle that. Circle this. Circle this. Multi.
America. Australia and South America can't yet be multi-regions because they currently only have one region each. This map shows Google's private global network, and each of the dots represents a place where data can either enter or exit that network. Usually those interchanges are with the public internet, but it's also possible to have private interconnections with Google's network. So let's take a closer look at what this network means. Normally, you'd expect data to travel on the public internet to the place that's closest to the destination. Then it would connect into the private network of that particular data center. But with Google's network, data can actually travel to the connection point closest to the source. And this
I think that is an important point. Network, ingress, and egress. Normal networks would route via internet to edge location closest to the destination. And this is as opposed to versus Google, where routes, so traffic enters from internet at edge closest to source. Enables interesting scenario, such as
This enables some very interesting scenarios. For example, you could have a single global IP address that could load balance across all of your servers.
Allows you to have a global IP address that load balance across all of your servers. Oh, or what?
Servers worldwide. When someone goes to that IP address, they would generally hit the server that's closest to them physically.
So when someone accesses that IP address, they would generally hit a server that's closest physically to the device. The device. Two of them. I mean, I was gonna elaborate a bit, but I don't know every single scenario, so
so they'd get really fast responses. But if that close server or region is overloaded, it can just load balance some of the traffic to another region.
Though if this nearest server is saturated, server or region, and traffic be load balanced to a region, to another region with preferable latency.
At a slightly higher latency. Because you can work with global IP addresses, this can sidestep a lot of issues with DNS.
Provides an advantage when dealing with DNS issues. Allowing you to sidestep most of some of them, or a lot of them.
Now, GCP used to have just one mode, where data would spend as much time as possible inside the private network, but it's now possible to opt for a normal network routing policy.
GCP used to have one mode, now has a normal that allows for that where network routing is done so normally, like the point above. Why? Because it's for a reduced price point.
To reduce the price somewhat, of course also reducing the functionality.
There is reduced functionality.
And this is a good time to talk a bit about how pricing works. One of the ways you might pay for a service is by provisioning a certain capability. You tell Google, make sure you're ready to handle this amount of load.
Provision. Make sure you're ready to handle X. Set GCP. What type or amount of load is expected to be utilized?
Have those resources sitting there and waiting for my stuff. In this model, you're paying for the resources to be ready for you, regardless of whether you wind up using them.
You're paying for the resources to be ready instead of needing to spin them up. And thus using them.
The other model is by usage, where you say to the service, handle whatever I use and charge me for that. Now, unfortunately, this isn't something that you generally get to choose one or the other. It's that the service is built to either be provisioned or to charge based on usage. Another thing you have to pay for is network traffic. Network traffic is always free on the way in, but it's on the way out it gets a little more complicated.
Okay, that's usage. Handle whatever I use and charge me for that. Network traffic. Free on the way in, ingress. Although there is a charge on the way out, egress. Gigabytes used. Okay, it makes sense.
In general, you're charged on the way out by how many gigabytes of traffic you send. But when you're communicating with other Google Cloud Platform services, this is sometimes free.
Okay. Although, if egress destination is within GCP, egress traffic sometimes it's free depending on specific service and where it's located.
Depending on the specific service and where it's located. In general, you don't pay to send data to other Google Cloud Platform services in the same region unless those services live in a particular zone.
Egress to GCP service. Caveats. Depends on the service. Depends on the location of that service. In general, you don't pay to send data to other GCP services. In the same region. Unless those services live in a particular zone. Can we get an example? I mean, so for example, every one of these points is a region. So if I'm sending it within a region and it's within my same zone, do I pay, or is it because there's particular services that are within a zone that are never free? Is what I'm curious about. That could use some clarification. Let's see if anyone in the Q&A have answered this. You explained the physical structure very well, but I miss any. That's not really useful anyway.
Security is a really important design principle for the Google Cloud Platform. If you watch those YouTube videos I linked, you'll see very clearly that there's a separation of duties and a lot of attention paid to the physical security of the data centers housing the GCP services. Beyond that, though, absolutely everything in GCP is always encrypted at rest. You don't have to turn on encryption yourself, though you certainly can and take advantage of the strong key management services they have. Key management and other access is all tied into the identity management, which is a core part of GCP. Network encryption is another thing to think about. All control information with GCP services is always encrypted, and all wide area network traffic between regions will soon be encrypted automatically. They're also moving towards encrypting all the local traffic within the data centers. But even with all of the network security stuff, the general model is to distrust the network. This is following the security best practice of defense in depth, having layers of security.
Oh god, it goes pretty fast. All control plane info encrypted. All plan traffic to be encrypted automatically, and moving towards and oops. All local traffic within data centers. Stress on core beliefs. Core belief. Distrust the network.
And Google's developed a whole distrust the network. This is following the security best practice of defense in depth, having layers of security. And Google's developed a whole security model called BeyondCorp that shifts access controls from the network perimeter to individual devices and users.
Shifts access controls from the network perimeter to individuals, the devices, and users. This allows employees to work securely without securely at any location, but without needing to use a VPN.
This can allow employees to work securely from any location without needing a VPN. You can read more about how Google has designed security into the Google Cloud Platform at this link here. Continuing on, from Google's perspective, you can't have a service that can only handle 1 billion web pages and then falls over. It has to be able to handle like trillions or more, in theory. Everything has to be able to scale, basically infinitely. And despite that scaling, nobody wants to be answering pages of things that have gone wrong, and especially not developers. So if it can be automated, it should be.
Okay, scalability must be unbounded. What does this mean?
And it can be automated. It can all be automated. That's basically one of the principles behind site reliability engineering. You engineer the reliability into the systems. You automate the things to respond appropriately. But there are still some guardrails in place to protect you from some mistakes and to help Google better manage their load spikes. Basically, a quota is how much of a particular service you're allowed to use, and some of these might be regional and others might be global. If you wind up hitting the limit for a valid business reason, you can get this changed. Sometimes Google might actually change these automatically.
Oh, crap. Scope is within regions. Regional, global. Changes to automatic. If you wind up hitting the limit for a valid business reason, and you can get this for a valid business reason, you can get this change sometimes. Google might actually change these automatically for you, but otherwise you can request that they be changed. Request quota will be changed.
Automatically for you, but otherwise you can also request that they be changed, and they'll respond to those requests in 24 to 48 hours, but they might say no, depending on what you're asking for. Also, it may be useful to know that you can query for your current limits, running this gcloud command.
For response or answer. And your quota is queryable with this command. Gcloud compute project info describe dash project my project ID.
We'll get into gcloud more later on. But in particular, this asks Google to tell you what your current limits are for this particular project.
This will ask GCP to tell you what your current limits are for a particular project.
And that brings us to the next topic, which is projects.
Okay. All right. Organization.
Projects are the primary unit of organization in Google Cloud Platform.
Okay. Actually, write that down. Projects are the primary unit of organization. GCP. Crap.
Will soon be encrypted. Kind of similar to what an AWS account is. In particular, every resource is owned by a single project, though it is still possible to share these resources across other projects, but it's still one project that owns and gets billed for it.
Projects own resources. Resources can be shared with other projects. Every resource is owned by a single project.
But your GCP account can have multiple projects in it, and you can group and control these in a hierarchy. Alright, this has been a really quick and high-level
Projects can be grouped
look at the Google Cloud Platform, but I hope you found it useful to understand a bit better how GCP is built. If you have any questions for me, please let me know. If not, please feel free to move on to the next lecture. Thank you. Okay, hello, Cloud Gurus.
Where are we? What section am I on? Okay, I think it moved on to the next section. Right?
Okay.
Yeah, it did. So I think I am over time. It's supposed to be done by 10. It's 10:40, and I actually have another Udemy to do on Twitch at 11, and I might move that back a bit because I need a longer break than just 20 minutes. All right. I don't think there's anything I need to do um, aside from checking out these Q&A questions, which doesn't seem too relevant to the content. Hi, ACloud folks. What does the ACloud even mean? My question is below. Is it possible to add this course to the ACloud Guru site? What? Absolutely, you can access this course on our own website, along with hundreds of other courses on the basics of cloud computing. Let me check that out. And let me note that here. Uh, oh, hey, this course is also here. Hopefully, is it free? Okay, I'll just do this in my own time. I think we are good for the stream. I'm going to be logging out. And thank you for watching. I'll be back shortly.